Okay, we are going to do lesson 1.3, day 2 today. Just to go over the warm-up really quickly here. So just a couple things here, if you're not in the classroom with me, just a couple things that I usually point out when I'm in the classroom. So this is a pre-response problem. This is what an AP problem looks like. This is your scoring right here. On some of the older problems, they don't use this scoring, but on this particular one they did. The newer ones, they still use this idea currently. So the E stands for essentially correct, P partially correct, I incorrect. And then depending on the question, each one kind of gets its own. There might only be one section. Maybe this one has 3 sections that are EPI. Maybe there's 2. It just kind of depends. All right, when you did the first one, and you said to describe the shape of the distribution, remember when we talked about if you're describing a distribution, you need to mention your socks. So when you look here, this one, sorry, this just says describe the shape. So actually we don't need our socks. We only need to talk about the shape. If it said describe the distribution, then we would need our socks. So describe the shape of the distribution. So we look here. It says the distribution is skewed to the left or towards lower values. So again, remember you want to think about putting it on its side there when you're looking at that stem and leaf plot, and you can see that there's that skew over there on the left, so there's a tail over there on the left. So for that one right there, pretty straightforward. So as long as you said that the distribution was skewed and you said the direction, you would have earned an E for that particular one. If you just would have said it's skewed, but you didn't mention the direction, so you didn't say it was left, then you would have gotten a P. Or if you just said it was not symmetric, you would have gotten a P. Or if you said it was not normal, you would have gotten a P. You wouldn't have said this at this point. We haven't talked about that yet. So then it asks, in order to motivate the students, the instructor of the class wants to report that overall the class performance on the exam was high. Which summary statistic, the mean and the median, should the instructor use to report the overall exam performance was high? Explain. So you want to make sure that you're doing both parts here. You want to make sure that you're picking the one, and you want to make sure that you're explaining why you're picking that one. So here, you know that it's skewed to the left. You know that you have 64 values. You have 32 values. So the median, if I take 32 values and I divide it by 2, I get 16. So that means 16 values are below the median, 16 values are above the median. So if I count here, 2, 4, and then I have 6, 8, 10, 12, 14, 15, 16. So the median is probably right around here. So it's in the, and this is an expanded one, so it's probably around, expanded stem and leaf plot. So it's probably around 85, maybe it's 86, but it's definitely, in that mid 80s. Since this is skewed to the left, the mean is going to be lower than it. So I'm going to say here, if I want to report that the performance in the exam was high, I'm going to report the median. It looks like, so I could say and explain, I could say here, well, looking at, knowing that there's 32 students, the median would be the middle point, so there'd be 16 students below, 16 students above. Counting, it gets me to a median at around 80, in that 85 to 89 range. Whereas since its distribution is skewed to the left, the mean is going to get drawn towards the skew because it's not resistant, so therefore the mean is going to be lower than the median. So in this one right here, I actually, when I just talked it through, gave a little bit more detail than the rubric does. So since the distribution is skewed towards the lower values, the mean will be pulled in that direction. Thus, the instructor should report the median to motivate her students. So for this particular one, to earn like full credit, the essentially correct here, they want you to make sure you chose the median and you had a good rationale based on the skewness of the distribution. You'd get a P if you chose the median but your rationale was weak, or your mean was chosen but the rationale was weak. You'd get I if no rationale is provided. So if you just said median and you didn't explain, you'd get an I. So even though you knew it was the median, if you didn't offer that explanation, you're not going to earn any credit. Or the mean is chosen based on a flawed rationale. All right, and the last one here, it says the mid-range is defined as the minimum plus the maximum plus the minimum divided by 2. Compute this value using the data above. Is the mid-range considered a measure of center or a measure of spread? And explain. So there's 3 things you need to do here, and you want to make sure you do all 3 of them. So first we're going to do is we're going to compute the value. And even though this math is minor, you've got to show your work to justify where you're getting the answer. So the maximum plus the minimum, they did give you those numbers up there, so make sure you read that opening sentence there, even though they're not in the stem and leaf plot. So you get that 79.5. So is the mid-range considered a measure of center or a measure of spread? Well, obviously, it's probably a measure of center because we haven't even gone over the measure of spread yet, but if you were not sure, if you think about what's happening here, is it's basically we're just taking both extremes and averaging them. So we're just kind of figuring out what the middle is. We're not really saying too much about the spread here. So this mid-range is considered a measure of center, and explain. So again, my exclamation can be just like what I just told you right there. All I'm doing is taking the upper value and the lower value and just averaging them. Okay, so the rubric says the maximum provides information about the upper tail. Sorry, so there's the number, identify the mid-range, and then the maximum provides information about the upper tail, more specifically the upper extreme value. The minimum provides information about the lower tail, more specifically the lower extreme value. By averaging these 2 values and creating the mid-range, we're creating a statistic that provides a halfway point between the 2 extremes. So the statistic is a measure of center. Okay. Again, here on this one, essentially correct if all 3 steps are essentially correct, partially correct if 2 are essentially correct, and I if at most 1 step is correct. So even if you said it was you calculated the mid-range correctly and everything was wrong after that, you still would have gotten an I. And then depending on your combinations there, you can earn up to 4 points on these open-ended, these free response problems, these frappies. So you could get, if you got 3 E's, you get 4, 2 E's, 1 P, you get a 3, 2 E's, 0 P, 1 E, 2 P, a 2, and then there's different combinations there for a 1. Okay? All right, here's your stats humor for the day. Here's 2 teachers hanging out in the teacher lounge, grading papers, reading the newspaper. And then this is my average student is doing great. Half my class thinks 2 plus 2 is 3, and the other half thinks 2 plus 2 is 5. Get it? Average would be 4. So the average student. All right. Again, here we go. We are now looking at section 1.3, day 2. We are going to be describing quantitative data with numbers. So the last thing here. So we've looked at our measures of center. So remember we had our mean and we had our median. We've done some graphs. Today we want to explore measures of spread in another graph. If you go ahead right now and you found the mean of this data set and found the mean of this data set, you should be able to answer this question here. What's the same about the 2 data sets and what's different? Again, you can pause the video, try it on your own, and then unpause when you're ready to return. So you should have found, obviously, that what's the same is that the means are the same. What's different? The spreads are drastically different. These values right here are very consistent. They are very close to each other. These values right here are very spread out, okay? So there is a difference. So the idea here is that just because we know the mean of the data set doesn't mean we understand the whole picture. We don't know everything. All right, measuring spread. So we're going to start talking about basically range quartiles and interquartile range. Some kids get confused here. Measuring spread, there's 3 measures of spread that we're going to focus on here. We're going to talk about the range, we're going to talk about the interquartile range with IQR, and then we're also going to talk about standard deviation. All right, so that will be the 3rd one. So I'm going to start with the range. So the range is very straightforward. It's just the max minus the min. It's incredibly easy to calculate. Is it a resistant measure of spread? No, it's not. If you have outliers, it's going to influence the range. Again, it's incredibly easy to calculate. It's a very quick one to calculate. That's why it might be used a lot. In that last warm-up example, I only knew the max, min, and min, so I could calculate the range. I wouldn't have been able to calculate any other measure of center. Quartiles. All right, so the quartiles. Quartiles basically splits up your distribution into quarters, so into 25%. So you'd have 25%, 25%, 25%, 25%. There are 3 quartiles. So we have Q1, we have Q2, we have Q3. So Q1, 25% of the values are below it, and that would mean 75% of the values are above it. Q2, another word for Q2 is the median. And then we have Q3, okay? The median, again, is your 50-50 point. Q3 had 75% of the values below it, 25% of the values above it. How do you find them? Well, again, we just said that Q2 is the median. And then Q1 ends up being the median of all the values that are less than the actual median. And Q3 ends up being the median of all the values that are greater than whatever the median is. So you find your median first, and then you kind of just look at the data set in chunks. Remember, to do this, your data has to be in order. The interquartile range, so the IQR, is Q3 minus Q1. This just gives you an idea of the spread of the middle 50%. So how spread out is your middle 50% of your data? Is the IQR a resistant measure of spread? So yes, you wouldn't have any outliers at this point, so the outliers aren't going to impact it. All right, here's your McDonald's chicken sandwiches, and it's the amount of fat, and they're already in order for us, so that helps us. I don't have to put it in order. So it says to find the value of the quartiles and calculate the IQR. So there are 14 sandwiches. So 14 divided by 2 gives me 7. If I split, so I want, the median is at the point where there's 7 values below it and 7 values above it. So if I split this right here, there's my median. Okay, so the median is that middle point. I don't have a value in the middle point. Remember, this is an even number of values. So when you have an even number of values, you average those two values. So my median, which is my Q2, is going to be 16. It's the average of 16 plus 16 divided by 2, so it's still going to be 16. All right, when I find my Q1, so my Q1 is the median of the values that are less than the median. So I'm only looking at these values. Now I have 7 values. I have an odd number of values. If I do 7 divided by 2, I get 3.5. So the 3.5th value, well, basically it ends up being the 4th value, right? So if I want to split these in half, it ends up being this value right here, okay? So Q1 is 10. Same idea up here. If I split this in half, so I've got 7 values, split it in half. Q3 is going to end up being 17. All right. So when I find the IQR is 17 minus 10, so it's 7. To interpret that, remember we like to interpret things in stat class, you can just say the range of the middle 50% for the fat grams is 7 grams. All right, so I'm just doing that interpretation there. All right, outliers. Outliers come up right now because the rule of thumb to find the outliers relies on using the IQR. So an outlier is a point or a data value that falls outside the pattern of our regular data values. We've kind of been seeing them anyways by eyeball. How do you identify them? So the rule of thumb that we're going to use is that an outlier is going to be, if I take Q1 and I do 1.5 times the IQR and I subtract that from Q1, anything less than that value is going to be considered an outlier. I'm also going to go in the other direction. So Q3 plus 1.5 times the IQR. Anything larger than that is considered an outlier. Okay? So to identify them, we're just going to use that rule right here. So back to those McDonald's chicken sandwiches, determine if there's any outliers. So before we found the IQR at 7, So if I did Q1 minus 1.5 times the IQR, that ends up being 10 minus 1.5 times 7, which ends up being negative 0.5. We don't have any chicken salads that have negative fat, unfortunately. And then to find the upper boundary, I'm going to do Q3 plus 1.5 times the IQR. So I've got 17 plus 1.5 times 7, so that ends up being 27.5. So anything less than this, again, no negative chicken sandwiches with fat, negative fat, or anything greater than that is going to be an outlier. So if I look at my data set, the only outlier I have is 28. So 28 is an outlier. All right, your 5-number summary. So it's pretty much just what it says. It's 5 numbers that summarize your data set. Those 5-number summaries are used a lot. They're displayed when we create box plots. All right, so your 5-number summary consists of the minimum, Q1, the median, Q3, and the maximum. So again, we display them in box plots. So the 5-number summary for the McDonald's sandwiches, we kind of already figured this out. The minimum would be 9. Q1 would be 10. The median would be 16. Q3 would be 17. And the maximum would be 28. Okay? All right. When we create our box plots, this is our chicken and sandwiches box plot. You only really need a number line. You don't, so you only need an x-axis. X-axis, you can create a y-axis if you would like, if you had more than one box plot, and then I would just stagger them or stack them on top of each other. This one, I think I have enough space here. If I start over here, I can actually use a square for each fat gram. So all I'm doing right now is scaling them. My smallest fat gram was 9. My largest one was 28. So I just started at 8 just to keep the even spacing. Again, if you wanted to just start at 10 and drag your line over there, that'd be fine. All right, so that 5-number summary is very important when we create box plots. So that's what we're going to do right now with that. But to make my box, I'm going to start with Q1 and Q3. So Q1 is at 10. It doesn't really matter how tall you make your box. If you wanted to make it really tiny, go for it. If you wanted to make it bigger, go for it. And this particular graph, I'm only drawing 1, so I can kind of use as much space as I want. If I was drawing 2, maybe I would only use 2 squares for the height, just to stay consistent, as we've talked about before. Q3 is at 17. So there's my start of my box. I'm going to connect top and bottom of my box. And then I'm going to figure the median is at 16, and I'm going to draw a line where the median is. All right, so I've got my Q1, my median, my Q3. Then I want to extend my whiskers to the largest value that is not an outlier, or the smallest value that is not an outlier. So in this direction, the smallest value in my data set is 9. That's not an outlier, so I can extend my whisker to 9. You can put a dot there or a line, however you want to. In the upper direction, I want to extend my value to my whisker to the largest value that's not an outlier. The maximum is 28, but that's an outlier, so I don't want to extend my whisker all the way to the 28. The largest value that's not an outlier is 23. So I'm going to extend my whisker to 23. Now, what do I do with that 28? Well, I want to mark it as an outlier, so I'm just going to come over here, and there's my 28. If you want to use an asterisk or a little star, that's fine too, but there's my outlier there, 28. All right, over here it says describe the distribution as seen in the box plot. So whenever we're asked to describe the distribution, we want to do our socks. So I'm going to start with the shape. So I wrote the fat grams are. So shape can sometimes be hard to see in a box plot. If you can't always see it, I'm going to show you how to do this on your calculator. You could always make another graph and kind of see what that graph looks like. Typically what happens whenever you have a whisker, there's like a tail there. So for this particular one, it's pretty straightforward. So I'm going to say it's skewed to the right. All right, so before we were kind of talking generically about where the center was or what the spread was. So I don't have to be generic anymore. So instead of saying the center, I'm going to say the median is at 16 grams. The IQR is 7 grams. Could you report the range for your measure of spread? Sure, but the problem is here there is an outlier, so we know that the range is going to be a little bit wrong. It's because it's not resistant to those outliers, so that IQR is a little bit better because it is resistant to the outliers. So the range is 7 grams, and I should put an E in there. And then I'm going to say there is an outlier at 28 grams. So for this particular one, we actually have these metrics calculated, so we're going to report them as opposed to just kind of talking about them generically, which is what we had been doing up to this point. All right, what I want to show you how to do next is how to do this on your calculator. I'm not really going to know if you create the box plot by hand or if you let the calculator create it for you. So I'm just going to show you how to do it on the calculator. On the calculator, we're going to use these chicken sandwich numbers again. So we're going to go back here to our calculator. I'm going to clear my list 1. So I just used the up arrow and then I cleared the list. And I'm going to type in 9, 9, 10, 10, 12, 15, 16, 16, 17, 18, 20, 23. I think I did that wrong. 28, 23, and then 28. Okay. So once I have all that typed in there, so there is an option to make a graph without an outlier. We're not going to do that one. We're always going to pick the one that shows the outlier. So that right there will be one graph that I will not use in this class. So when I'm back here on my calculator, I'm going to go to second y equals. So again, this is where our stat plot is. We've seen this before when we made our histogram. I'm going to go turn it on. I'm going to go over to that box plot that has the dots with it. So it's the 4th choice. Going to press enter. To press enter to put that black box around there. The X list is where my data is. My data is currently in list 1. The frequency is the weighting. I want to leave that as 1. The mark is just marking if there's an outlier or not. I'm going to where the outlier is, so you can pick whatever one you want. Again, color, you can do whatever color you like. And then our favorite zoom in stats class is that zoom 9. So then I go to that zoom 9. Oops, it looks like I have a line in here. Let me turn off this light here so you can see this a little bit better. So I have a line right now. I'm going to get rid of that line. And it still doesn't want to focus on me. All right, I guess it's better with the light on. Okay, here, if I put it over here, the glare is not so bad. All right, so here's my box plot. If you hit the trace button, what you'll notice here is you can use those left and right arrows So right now I'm over here. It tells me down here that that's my minimum at 9. I move over, Q1 is at 10, median is at 16, Q3 is at 17, X is at 23. So this isn't my maximum, remember? It's the largest value that's not an outlier. And there's my maximum at 28. So you can draw the box plot in your calculator and just copy it from your calculator onto paper. It's really probably the easiest way to do that. I also think, just a reminder, we did talk about this the other day, to find those quartiles on the calculator. So if you go to stat, you go to calc, you go to 1-var stats, list 1, and you hit calculate. Remember, we leave that freak as 1. So again, when you scroll down here, there's your 5-number summary. So there's your min, your Q1, your median, your Q3, and your max. So again, you can find that in that 1-var stats. All right. So 1-var stats and then your stat plot. Okay, this section right here is definitely, this is the most important measure of spread as far as statisticians are concerned. This is the one, all your distributions are going to be based, all their curves are based on these standard deviations, so this is going to be your most important value. This most important measure of spread. Then the IQR would be second. So measuring spread, the standard deviation. So it says in the distribution below, how far are the values from the mean on average? So there, in this particular one, there's 8 values here. And most kids figure that the mean is 4, which it is. If you want to calculate it, go for it. So the mean is 4. And then I say, on average, how far away do you think these values are? So like this value is 1 away. These ones are 2 away, but there's 2 of them. This one is 3 away. So, you know, maybe about 2 is what kids kind of usually say in the classroom. So the standard deviation, what does the standard deviation measure? So the standard deviation is just kind of measuring your average distance. So it measures your average distance of the observations from the mean. So it's like your typical distance there. So it's calculated by finding an average of the squared distances and then taking the square root. This average squared distance is called the variance. In symbols, the variance S of x is given by this. All right, so that's our notation there for the variance. To find the square root, to find the standard deviation, then we take the square root. So again, when we go through this calculation here, basically what we're doing here is we are finding the distance each observation is from the mean. We're squaring the distances. Then we're averaging those distances. If you notice here, we're not dividing by the total number. I'll explain why shortly, but we're dividing by n minus 1. And then the standard deviation is just the square root of that average squared distance. All right, so again, your standard deviation, what is it measuring? It's kind of telling you what your average distance is, or your typical distance a value would be from the mean. All right, similarities and differences. So similarities, these 3 are all measures of spread. Okay, so we talked about that a little bit. These are not measures of center, these are measures of spread. So all 3 of them are giving us an idea of how spread out our data is. What's the difference between them? The difference is how they're calculated and if they're resistant or not. So the range, it's just calculated using 2 values, max minus the min, not resistant. IQR, calculated using 2 values, Q3 minus Q1, resistant. Standard deviation, calculated using every single value, can be influenced by those outliers, so not resistant, okay? All right, how's the standard deviation calculated? So again, I showed you the formula already. What's the variance? We're going to go through it using this data set right up here. If you don't believe me, so if I have 1 plus 2 plus 2 plus 3 plus 5 plus 6 plus 6 plus 7 plus, that's it. And I divide that by 8, I get 4. So my mean here is 4, okay? So the x bar for this particular problem, I'm going to use sample notation here. We're going to say that this is a sample, this isn't a population, is 4. All right, so the first thing I'm going to do here is I'm going to create a little table. I'm going to write down all those data values there, all those numbers. So I've got 1, 2 2s, a 3, a 5, 2 6s, and a 7. Now remember, what's my goal here? My goal is trying to find the average distance. So I'm going to do x minus x bar. So how far away are my values from the mean? I'm trying to find that average distance from the mean. So I calculate these values here. Okay. So again, goal here, try to find that average distance the values are from the mean. So if I added all these up right now, what would happen? Yes, I would get 0. And how can I find an average if the sum is 0? So I need to do something to get rid of those negatives. So some kids will suggest, well, why don't we take the absolute value? We could take the absolute value. There is a deviation measure that takes the absolute value, but it's just not what our mathematical formulas are based on for our distributions. So taking the absolute value doesn't work. So we end up actually squaring everything. So when we square things, we'll get rid of the negative, but then we also the values that are far away have a little bit more weight in the overall calculation. So I'm going to take these deviations and square them. And then now I'm ready to average them. So basically what I do here is I want to take the sum of those squared deviations. So the sum of these numbers right here ends up being 36. Okay, again, I told you I wanted to take an average. So you would tell me probably I should just divide it by the number of values in my data set. So why don't I just divide that 36 by 8? Well, the problem is that if this is a sample of the values, then it's not the actual population. So if it's not really the actual population, and I'm just using a sample to estimate something about the population, I probably shouldn't divide by the actual number. Maybe I should divide by a little bit less than what the actual value is in the population. Because if I divide by something that's a little bit smaller, I'll get a number that's a little bit bigger. And then therefore, when I state my sample standard deviation or my sample variance, if I'm wrong, I most likely will be overestimating instead of underestimating. So I'm going to do the n minus 1, so that's going to be 7. Again, right now I have the squared deviations. So there's your variance right there. So I've got my 36 divided by 7. Don't ask me why I wrote so many decimal places. So that's my variance. Well, the problem is my original data was not in squared units. Why would I want to keep it in squared units here? So I want to go back to what my original data was. So now I want to take my square root. So when I take the square root, this right here is my standard deviation, and I have 2.26, I'll just use 3 decimal places, 8. And whatever the units are, this one now is not squared anymore. These other ones were squared units. All right, so basically what I'm saying here is on average, the values are 2.268 units from the mean. That seems pretty reasonable, right? Because up here we said, hey, what's it about 2, right? So this seems like, yeah, this probably makes sense, right? So on average, that's how far the values are from the mean. Seems like it's reasonable, right? What does it mean? Well, so, the standard deviation gives you an idea of how spread out your data is. So if I know my mean's 4 and on average the values are 2.268 from the mean, well, they're really not that far away then, right? So if somebody told me that 12 was the data set in this value, I might think they were a little nuts, because 12 would be so if I did 12 minus 4, and I divide it by that standard deviation I just got, well, 12 would be 3.5 standard deviations away from the mean. I'm not really sure that 12 is actually in that data set, so I don't know that I believe that person. So the standard deviation just kind of gives me an idea of how spread out things are, okay? All right, some properties of standard deviation. So a couple things here. So standard deviation just measures spread about the mean. So again, it is only measuring how spread out your data is around the mean. The standard deviation is always greater than or equal to 0. So again, it can be equal to it. It's equal when there's no variability at all. So if all the observations are exactly the same, then it would be 0. It's never going to be negative. SX has the same units of measurement as the original observation. So if your original observations are in inches, then your standard deviation is also going to be in inches. Like the mean, SX is not resistant, so a few outliers, as we can see there, if I square those few outliers, that distance away, it's going to get pretty large. And then the fact we're using square deviations makes it more sensitive than X bar even to those extreme observations. I did mention before something about, well, we divide by n minus n or n minus 1. So there are situations in which we would just divide by n instead of dividing by n minus 1, but we're only going to divide by n if we're actually calculating the population standard deviation. So we are certain that we know the answer that we get is the value of the population. So again, and that notation is a little bit different. We use Greek letters when we're talking about population values, so it would be sigma x. But again, in that case, we would be absolutely certain what the value was, so we're not trying to estimate what the sample value is, so we're not concerned about being wrong in our estimate. Again, just like before, so here's another example here. If we were in class and we had the time, I would have you try it on your own. I'm going to quickly just show you the answer here. So you would find there's my x values, there's my deviations, there's my squared deviations. That's my variance when I take the square root. So on average, the student study time varies 34.71 minutes from the mean. Okay, again, if you want to try it on your own, just pause the video, make sure you can get the same answer as me. You can, for the most part, use your calculator. So if I use, let's say I'll just use these values here. So I'm going to clear those out. So 0, 25, 30, 60, and then 90. So again, we go to that familiar stat place, that calc 1-bar stats. I'd hit calculate. So remember, the mean is calculated the same way regardless if you're talking about a sample or a population. The standard deviations are calculated differently. The SX1 is the sample one. That's going to be higher because remember the denominator is different here than the sigma one. For the time being, we're going to focus on using the SX1. So we're always going to be having that n minus 1 in our denominator. Okay, so what factors should you consider when you're using summary statistics? So again, it kind of goes back to looking at the shape there. So on page 66 of the book, it says here, so choosing a measure as a center of spread. The median and IQR are usually better than the mean and standard deviation, describing a skewed distribution. So if you skewed, median and IQR, or distribution with strong outliers. Use X bar and SX for only reasonable symmetric distributions that don't have outliers, okay? Remember, your graph is always going to give you the best picture. Numerical measures the center and spread, report specific facts about distribution, but they're not going to give you the shape. So really that SOX gives us a great picture of everything that's going on there. All right, and there's the practice problems for this note set.